In this video, we're going to be going over the May 2022 Paper 2 Timezone 1 exam. Question number 1. Boris recorded the number of daylight hours on the first day of each month in a northern hemisphere town. This data was plotted onto a scatter diagram. The points were then joined by a smooth curve with minimum 0.08 and maximum 0.616 as shown in the following diagram. Let the curve in the diagram be y equals f of t, where t is the time measured in months. When you read something like this, make sure you underline so that you remember, since Boris first recorded these values. Boris thinks that f of t might be modeled by a quadratic function. Write down one reason why a quadratic function would not be a good model for the number of hours of daylight per day across a number of years. So if you remember, a quadratic function is basically in the form of a parabola. That's the graph of a quadratic function. So in a parabola, you would have a minimum and absolute maximum depending on which way it's opening. That's not what's happening here, because you know that in terms of the number of daylight hours on the first day of each month, it's going to fluctuate month to month. One of the answers that you can write down is that the number of hours of daylight per day across a number of years is cyclical. The idea that it is cyclical, that there is no absolute min or absolute max, that it's going to fluctuate back and forth, is something that on the IB exam they would accept. So these are the answers that IB would accept. Annual cycle for daylight length. There is a minimum length for daylight. It can't be negative. A quadratic could not have both a maximum and a minimum. Or you could say the number of hours of daylight per day across a number of years is cyclical. So it's the idea that this is going to go down and up and then down and up, and it's going to follow this cycle over and over again. So in a quadratic, you know that it's going to continue to be either all the way down negative towards negative infinity or all the way up towards positive infinity. Paula thinks that a better model is f of t equals a cosine bt plus d, where t is greater than or equal to 0 for specific values of a, b, and d. For Paula's model, use the diagram to write down the amplitude, the period, the equation of the principal axis. So the way this works in terms of the equation, a is going to be your amplitude, b is not the period, but the period is 360 divided by the absolute value of b, or you can say that b is equal to 360 divided by the period, and d is going to be your principal axis. Okay, so let's talk about what these mean. And because they want the equation of the principal axis, you know you're going to write it in the form y equals, because it's going to be a horizontal line. So in terms of amplitude, amplitude is half the distance between the minimum and the maximum. So when you go to find amplitude, it's going to equal half the difference between the max and the min. So here the maximum value is 16. The minimum value is going to be 8. So this means that 1/2 of 16 minus 8 is 8 is equal to 4. So the amplitude is equal to 4. Amplitude is always positive. The value of a in the equation is not necessarily always positive, but amplitude is always positive, because amplitude is half the distance between the minimum and maximum, and distance is always positive. So then we look at the period. So the period is how long it takes the graph to complete one full cycle. So one full revolution. In this case, you notice that here is my cosine graph. You're going to go up to the max, and then you're going to come right back down to the min. So that means that my period in this case is going to equal 12. So the period is going to equal 12. The principal axis is the line that is going to cut this graph completely in half. So what happens with these graphs is that they are cyclical. So you basically start at the principal axis, you're going up, back, down. Eventually you would go back if you were to continue this, and then you would continue up, back, down, back. So this is basically what's happening with these graphs. So the principal axis is 1/2 the max plus the min, basically the midpoint, the middle line. And so here it's going to be 1/2 of the max, which is 16, plus the min, which is 8. So 1/2 of 24 is equal to 12. And because they're asking you for the equation, you got to make sure that you write the equation as y is equal to 12. This is a 4-point question. You're going to get 1 point, 1 mark for the amplitude, 1 mark for the period, and you're going to get 2 marks for the equation of the principal axis. You will get 1 mark for writing y equals, and then the other mark is going to be for saying the 12. So it says, hence or otherwise find the equation of this model in the form f of t equals a cosine bt plus d. So I'm going to bring part C right here. One of the things that we still haven't figured out is b. If you remember, I told you b is equal to 360 divided by the period. So in this case, we found out the period is 12. So that means that the value of b is 30. Another thing that we have to be mindful of is the general shape of these graphs. So when we have y equals a sine of x and you have a positive a, the sine graph starts down, it goes back this way. Okay, when you have y equals negative a sine of x, it is going to be a reflection. So the sine graph is actually going to go down and then it's going to go back up. When you have y is equal to a cosine of x and it's a positive cosine, the general shape looks like this. So right now, when you have a negative cosine, you're going to see that it almost looks like a little hill. So if I were to compare these models to what I see on the picture, I notice it is a cosine graph and it's actually going down like this one right here. And that tells me the value of a is actually negative. So here for the equation, I'm going to have f of t is equal to a, which I'm going to write negative 4 because the amplitude is 4, but the value in this particular graph is going to be negative. Then it's going to be the cosine parentheses of b, which we figured out is 30t, and then the equation of the principal axis was y equals 12, so that means that d is equal to 12. So the correct equation is f of t equals negative 4 cosine of 30t plus 12. And that is a 3-point question, so it's a lot of points, one for each correct variable that you're substituting. For part D, for the first year of the model, find the length of time when there are more than 10 hours and 30 minutes of daylight per day. So in this case, 10 hours and 30 minutes is going to be 10.5 hours. So right now, this 10.5 hours refers to the number of hours of daylight per day, which in our graph, we know the hours of daylight per day is our y variable. Okay, it's going to be basically our y-axis. And so what you want to do is take your equation, negative 4 cosine of 30t plus 12, and you want to make it greater than 10.5. And you want to make it greater because it says when there are more than 10.5 hours. You need to understand that on the IB exam, you're going to get points for method. That means points for showing your work. In this case, you would get 1 point just for setting this up. Even if you got the equation incorrect, you're going to get what's called follow-through points for just taking your equation and making it greater than 10.5. Then how do you solve this? This is something that you can solve in your graphing calculator. So we're going to take your graphing calculator and we're going to go to y equals. And we're going to enter both sides of the equation. So we're going to enter negative 4. Remember, there's an actual negative button in the calculator times the cosine of 30t. But in the calculator, you're always going to click this x button, okay, xt, theta, n. It stands for all of that. Close parentheses, plus 12. Then you're going to make the right-hand side of the equation, the next equation, 10.5. Before you press graph, one of the things that you want to do is adjust your window. And when they give you a graph like this, you're going to take advantage of the window they gave you. So notice what we mean by window. So right now, if we take a look at the x-axis right here, notice that we're going from 0 to 12, and it looks like we're going in intervals of 3, 6, 9, 12. So we're going to do the same thing. Remember that this test is timed, and so you don't have a lot of time to waste. And you're going to take advantage of this fact. Go to the graph. You're going to make your x minimum 0. You're going to make your x max 12. Your x scale is going to be 3. Because it's showing me from 0 to 12 and it's going by increments of 3. When I go back to the graph for the y-axis, I'm going to see that I'm going from 0 to 16 and it's going in increments of 4. So I'm going to do the same thing on my graph. So I'm going to make my y minimum 0, I'm going to make my y maximum 16, and I'm going to make my y scale 4. So if your graph does not look like mine right now, one of the things that you need to do is make sure that you are in the correct mode. So under mode in the calculator, make sure you are in degree mode, because if you happen to be in radian mode, just watch what happens to the graph. That's not what you want. So make sure when you are in mode for the IB exam, you are doing this in degree mode, okay? So now when you go to graph, you're going to see that it looks normal. Now, what we want to get from this graph are the 2 points of intersection. So you're going to go to second trace. You're going to go to option 5, which is intersect. Right now, I'm going to go with my left arrow close to the first intersection. I'm going to press enter 3 times, and then it's going to give me the point of intersection as 2.2658562. So I'm going to write that down on my answers. So right now, I get that T is going to be about 2.2658562, and I encourage you to really fast jot down like all the values that you see in the calculator, so that way you can round later on, because if you make a mistake rounding, you run the risk of not getting credit, whereas if they see the full answer and then you happen to make a mistake rounding, unless it is a rounding question, you should get the full marks. So I go back to the calculator and I do the same thing again. I'm going to go to second trace, which is calculate. I'm going to go to find the intersection number 5. Then I'm going to use the right arrow on my calculator to move towards the second point of intersection. I'm going to press enter where it says first curve. I'm going to press enter where it says second curve, and you press enter for guess. Guess is not the answer. So now I'm going to go ahead and write down this second point of intersection, which is 9.73411438. So that's basically time 1. Then at time 2, it's going to be 9.73411438. This is from the calculator. So the question becomes, for the first year of the model, find the length of time when there are more than 10 hours and 30 minutes of daylight. So basically what we're doing in the calculator is that we're trying to figure out at which point the graph is going to be about 10.5. And so here and here are my point of intersections. Those are the answers that I found, which were approximately 2.2658, blah, blah, blah. And the second one was 9.734, blah, 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 dot, dot, dot. Anywhere above, this is when the graph is going to be greater than 10.5. And so that's what I'm looking for. So the last thing that I have to do is subtract these two values. It's going to give me about 7.4682876. You put this in your calculator, which is approximately 7.47 months. And this is going to be your final answer for part D. Okay, so then we go on to part E. It says the true maximum number of daylight hours was 16 hours and 14 minutes. Calculate the percentage error in the maximum number of daylight hours Boris recorded in the diagram. So if we look at the graph, the maximum number that we have is 16. So the question becomes, find the percentage error between 16, which is your estimate, and 16 hours and 14 minutes, which becomes your exact value. You go to your formula packet, you're going to go to topic 1, and you're going to find the percentage error formula. So right here is the percentage error formula. They tell you VE is the exact and VE is the approximate. So right now we have to take this exact amount of 16 hours and 14 minutes, and we're going to have to convert this to just either hours in terms of a fraction or a decimal, or we can convert it into minutes. Now, some people think that this is equal to 16.14, and that is incorrect. If you remember, there are 60 minutes in 1 hour. So if you're going to convert 16 hours and 14 minutes, you got to think 14 minutes out of 60 minutes for 1 hour. In your calculator, 14 divided by 60 is going to give you 0.2333, and if you go to math fraction, it'll actually turn that into a fraction, so 7/30. So if you want to take 16 hours plus 7/30, it's going to give you 16.2333. And again, if you go to math fraction, it's going to give this to you as an improper fraction. So now this is 16 hours and 14 minutes written as a fraction so that you can go ahead and do this easily. So now I know that 16 hours and 14 minutes is going to be equal to 487 over 30. So in terms of the percentage error formula, the percentage error is going to be the approximation, which is 16, minus the exact, which is 487 over 30. And do not get scared of the fractions because your calculator is going to do all of this for you. Divided by the exact in absolute value times 100 and percent. But the percent symbol is literally just decorative, like you're not actually pressing percent anywhere in the calculator. In your calculator, you can go to alpha y equals, and I know that there's some other ways that students find the ability to put this as a fraction so you don't make mistakes. And you're going to put 16 minus, and again, you're going to put this in a fraction form. So 487 over 30, and you're going to divide that by 487 over 30. So you're going to figure out this entire answer, and you're going to multiply this by 100. Now you have to realize that even though the answer is given to you as 700 over 487 negative, you have absolute value symbols. Percentage error is never negative. It is always positive. And if you want to change this into a decimal, you can go back to math, and now I can get it into a decimal. So my answer is going to be 1.43737, which is going to be approximately 1.44%. And remember what I told you, you are not going to write down the negative because of the absolute value. Your answer for percentage error is always going to be positive. So the final answer is 1.44%.